Hello, everybody. My name is Dariusz. I'm a JavaScript developer at here.com, the company which is also known as Nokia. We are developing maps there, but I won't be talking about maps. I will be talking about some other stuff. This is also my first JavaScript presentation, so So in the end, I hope it will be at the end like this, not like this. It would also be nice if after the presentation you would give me any feedback. What did I do wrong? What did I do correct? Etc. And the topic is pushing the web to the limits. So when we are talking about limits of JavaScript and the web frontend, we can mean many things. There's the performance issue, so everybody knows that performance in JavaScript isn't the best. So you can write a native app which will be way faster. I will focus on my second favorite thing about what's limiting us in JavaScript, and these are APIs. So like Balmer, I'm crazy about all the different APIs which we have right now in HTML5 and so-called Web 2.0. I just checked out a list of some APIs which are hot right now. So the Get User Media, which probably a lot of you already heard of, WebRTC, WebGL, there's WebCL, WebSockets, WebCrypto, Web anything. There's ambient light proximity to detect the ambient light on your devices. There's the screen orientation, motion sensors, etc., etc. So this is just a short list of the most interesting APIs I think are available. I will focus only on these 7. And the first one is Get User Media. So Get User Media already was proposed in 2010, if I'm not mistaken. It was supposed to be able to plug into your camera on the device, plug into your microphone, so that you can talk to your machine, you can record videos in JavaScript without anything else. And this could be also used for many different purposes, right? You could upload photos on web apps, etc., etc. The code for this is also really simple. You just get user media from the navigator. There's also in WebKit and Mozilla you have to prepend right now something. Then at the very end, you call Get User Media, define what do you want to choose. Do you want to have video and or audio? And the callback getStream after the user will allow you to share the video. And you set the video source element to the stream you just got in the getStream function. The ending result is this. So you have embedded the webcam into the HTML element. Nothing fancy, but at least right now it's nothing fancy. You can't really do anything else with this. It's just a video feed from the camera. But you can add some video manipulation. Normally, also you can just manipulate the video with CSS if you want. So there are CSS filters. You could just as well add a blur filter to the video to blur the image somehow. You can grayscale it, and so on. But you can also use canvas. So in this case, we would, after requesting the video to the video element, we request the animation frame with the draw function, and inside of the draw function, we draw the video element into a temporary canvas. Then we get the image data from the canvas, and we go crazy. So in this case, we are just creating a grayscale version of this video we just retrieved. We put image data to the normal canvas of the manipulated frame, and we end up with a grayscale video. So just one small function without much of work to manipulate the pixels, and we can do grayscale, we can do a lot more. Another technology, the second one, is WebRTC, which can be tied to Get User Media. RTC stands for real-time communication. So how many of you did something in WebRTC? 1, 2, 3, 4, 5. Okay, a bit. So WebRTC, like I said, it's supposed to be something, you could say that's something a bit similar to WebSockets. You transfer video or audio or any other content between two machines without, preferably without any server interaction. It's so far supported only in the latest Chrome and the latest Firefox. And in Firefox also, at least I think that in the current stable version you have to change some configuration value. In Chrome it should work out of the box right now. Unfortunately, mobiles don't support it yet outside of Firefox for Android. Sadly, even Firefox OS doesn't support this yet. I know they want to support this. Hopefully soon it will be available. Okay, so I already asked how many of you have used it. It's simple in the end. I was worried it will be complex, it will be complicated, that you would have to take care of something like sockets to get the correct data, to transform the data in some way. So after some short coding session yesterday, I managed to create a really simple example. At the very beginning, we get the user media, we set it to the video element, and we also set the stream to a global variable local stream. And we create two peer connections. The first one is RPC, so called PC1. The second is PC2. We also set the ICE callback. So WebRTC supports two standards for transferring data. It's STAN and ICE. I think there was one more standard, but right now it's not supported in any browser. ICE is supported in both browsers. On the second machine, we also said that when we will get the stream back, then we call get remote stream, which will set the stream to the second video element. Finally, we call add stream, which will attach the stream to WebRTC and send it further to the second machine, and we create the offer. So I omitted a bit of code here, but in the end it goes something like this. PC1 creates an offer, PC2 accepts this offer and replies back, and PC1 will acknowledge that it was accepted. So basically it's a normal handshake mechanism known from HTTPS or any other technologies. And here I omitted the server, so if you see servers is null, that means that I won't be actually transmitting data anywhere. And like I said, RTC is a peer-to-peer connection process, you don't need servers, but you somehow have to send the information to the second machine that, hey, I'm here, I want to start RTC with some other machine, and this is what we should append the create offer to. So on create offer, we should call some AJAX or WebSockets or any other technology which we prefer to send the data to the other machine. Then the other machine will correctly send data back, etc., etc. Here's the reply, here's the example, which failed actually, because in the second window you should see the correct stuff. Let me try this again. Okay, demo failed again. I mean, first time today. Sorry, so you should see the second screen of the second video of me and the second screen. Something went wrong, so hopefully I'll change it in the presentation I'll post online. Yeah, so that's it for WebRTC. Also, here's the thing about WebRTC. It's like I said, it's supported in Firefox and Chrome, but there are still sometimes it fails. So maybe because I'm not connected to Wi-Fi, it's failing here. Okay, the next one is Vibration API, which is a short and boring topic. There's no support in browsers or in any mobile devices, so also I can't demo anything. This is a future technology which should come hopefully soon. There is a ticket for Mozilla which should be resolved soon. I think there's already a patch incoming. And the API is really simple. So there's only the vibrate function, which vibrates. If you pass a normal integer, it vibrates once for the specific number of milliseconds. Or you can pass an array. So in this case, we would vibrate the Final Fantasy Victory fanfare. So it goes like, I won't sing it, don't worry. It's like, it vibrates for 50 milliseconds, then 100 milliseconds waiting, again 50 milliseconds, 100 milliseconds waiting, and so on until the very end. So a useful example for this is for tapping on links. We just query all the links on the website, and whenever they are clicked, we vibrate for 300 milliseconds. So simple, and it should be also helpful for future web development. Web notifications, another topic, which is already implemented, but it's also a bit buggy. The example is really simple. We request the permission. If it's granted, we create a new notification, and we set the title, we set the body, we set direction and language if we want to. Right now, I should be able to click call notification and it will show, but I already tested it that this doesn't work. This doesn't work because of the full screen mode, so it seems to be a bug in Chrome. Right, so if I click this again, I get two notifications, the one previously and the one currently. So the notification standard is in draft in W3. See, it should be soon available, but as you can see, it's still a bit buggy. Okay, back to the presentation. Okay, next thing is cryptography. So there are already many JavaScript libraries which happen to do something in cryptography to encode passwords in MD5 and SHA and anything else. But there are also many other use cases for cryptography. For example, we have the dreaded DRM, which to encode videos with, which, for example, is needed by some providers, for instance, Netflix. And turns out that Netflix loves HTML5 only because they introduced the DRM stuff in IE. This was actually done thanks to Microsoft, who'd guess. So Microsoft introduced DRM support in IE 11 in Windows 8.1. And thanks to this, you can play Netflix videos in straight HTML5 without any problems, so to say. This isn't so well documented yet, so I didn't know how to present this specific example. There is a library by Netflix, which I didn't include, unfortunately. There's a library by Netflix to show information about the whole cryptography stuff. But there are also other things. For example, you can just generate an HMAC key with SHI, and you have a callback uncomplete, which so it should fire. So it should fire in a few hundred milliseconds. On slow machines and fast machines, it should be really fast. Normally, right now, the JavaScript implementations aren't using web workers or anything asynchronous, so it actually blocks the browser if you want to encode the password in some complicated way before sending it to the server. So the API isn't as simple as the vibration API, but it should be simple anyway. You just generate the key and say what key do you want, and then sign the data that you want to sign. So for example, here the string at the very top. You sign the data, and uncomplete, it's already signed. There's a polyfill called Polycrypt, which tried to introduce everything from the cryptography API. So right now, this is the Polycrypt library, and when I just click start, it failed. Probably it failed because I'm not connected to the internet. So I tried it a lot of times, and it works all the time. Let me connect and try again. So as you can see on the list, it generates a lot. It is able to generate a lot of stuff. You can generate an AES key, RSA key, some SHA digests. Okay. Try again. Yeah, that's better. Okay. So now everything passes, and as you can see, it takes a bit of time. So it takes a few hundred milliseconds. And if we would have really web cryptography support, it should take just single milliseconds without any issues on the client side, without blocking anything. The next topic should be a bit more interesting, I hope. Did any one of you play with WebCL, or also known as River Trail, so parallel computing in JavaScript? Anyone? Okay, maybe it will be even more interesting. WebCL stands for Web Computing Language. This is a thing which was proposed by Intel based on OpenCL to go straight to the CPU and the GPU without passing through the browser, which is, so the JavaScript is running in the virtual machine, it's slow, it doesn't allow us to do much things. If we would go straight to the CPU and GPU, it should be good enough. So the main ideas were, what if we could run normal C code for advanced mathematical operations, feed the code straight to the CPU and GPU, and also running code in parallel on all available cores like with web workers. So we combine the three best things. In the end, it should be hard. Turns out it's not that hard. We have to introduce, first of all, a kernel which is written in C. So this isn't straight JavaScript, sorry. It's just like WebGL. You also have to know some C to write the shaders, etc. So this simple example just gets a random number and aligns it a bit. This is a kernel for the application, and here's the JavaScript for the application. First of all, we get the available platforms, which on this MacBook Air, for instance, is just the CPU, since the GPU is integrated. If you would have an NVIDIA card, AMD, something like this, then you have also the GPU available. Then we have to create a buffer to allocate the memory. We create the program with our kernel source, which I just showed. We finally build the program. And at the end, we set the argument to have our bufferand. So this is already the thing not in this slide. We created some predefined random numbers in JavaScript. We create the command queue, we write the buffer, we execute the kernel, we finish, and we send the data back. In the end, we have the numbers generated. And like I said, actually, I didn't say that, sorry. WebCL isn't supported in the major platforms yet. There are 3 extensions. There's an extension wrote by Nokia for Firefox. There's a special build of WebKit by Samsung to also introduce WebCL. And there is an extension by, I think, Motorola to Node. So it's not browser supported yet. No browser vendor wants to support it. It's only the telecoms, it seems. And for the Firefox demo, so this is what I just showed, a really, really simple thing. Whenever I just refresh the page, I calculate the numbers from WebCL. So this isn't anything interesting, but this is a River Trail demo for parallel computing, which was created by Nokia. So here we can run a special particle demo in sequential mode. So this is straight JavaScript in WebGL, and parallel mode. Parallel mode will also introduce WebCL. So when I run this in straight JavaScript, it's 10, 11 frames per second. And sometimes it slows down when we see a lot of particles. So right now we don't see any particles. They should come in a second. Yeah, there we go. Yeah, so now it slows down even more. And there we go, 8 frames per second. Sometimes while running this demo, it was even slower. So now if I introduce the parallel calculations in WebCL, it's like this. So we have 60 frames per second, aside of an occasional slow stop, which is probably because of the machine. And remember, this is running on CPU. If it would be on GPU, it should be hopefully even, well, not faster in this case, but you can have even more complicated stuff. If you would browse around a bit for WebCL, then there are many different mind-blowing examples, which unfortunately are mainly internal. So there are many videos from Samsung, from also Nokia, which show really crazy stuff done in WebCL, some calculations for, mainly for 3D, but sometimes you can even see extra stuff not done in 3D, but for advanced mathematics. And next thing. Okay, so that was everything JavaScript, apart from the last thing, which was also a bit of C. The last topic is CSS shaders. So sorry, I know that this is meet.js, it's JavaScript and everything, but CSS shaders are also an interesting topic. To create a shader, we have to pass a URL to define what shader we want to use. So in this case, I pass the flag VS shader, and I pass TXF as the parameter that I want to rotate by 45 degrees. The shader looks like this, so it's also fairly simple. We just modified the position to a cosinus with a custom function, and we project it back. So if you use WebGL, you probably know this. It's not complicated at all. And the ending result is, so this is a WebKit filter. I added a bit more and introduced animations, and the end example is this. So we are animating a normal div with using CSS animations and a shader created in WebGL. I mean, in WebGL, sorry, just a normal C shader, which could also be used in WebGL. So this is normal HTML context. You can select it, you can save the image if you want, you can do anything you want with this. CSS shaders are already introduced in Chrome as an experimental technology, and in Firefox I think you can also add a flag to the config to enable them. They seem to look really cool, and they are really cool, so you can try experimenting on them on your websites. Okay, so this was my last topic, and the GIF didn't load because of the lack of internet. That's better. Using new APIs is easy if you want to use them. Combining the APIs is a bit harder, but still manageable, as you can see. So I really encourage everybody just to check out the new APIs that they are. So not only don't stay with W3 Schools or any other documentation source you want to use, just go out, check the specifications posted by W3C, by WG, and you can also, every one of you can use the new APIs and learn from them. Thank you.
We have
Questions?
4 minutes for questions.
Maybe at least one.
Hi.
Hi.
Hi. So one question, is it possible to allocate memory using WebCL? I mean in this C code, and what happens if I allocate a block which is simply too big, whatever it means?
Okay, so in this...
Because in Linux you can actually allocate a memory block which is bigger than the available memory.
But,
and malloc never returns null.
Sorry, you mean in C you can allocate more, right?
Yep. Mm-hmm.
So in this specific example, I mean, you create a buffer, right? So you could say that this is somewhat of allocating the memory. You also have to specify, is it a readable memory, is it writable memory? If you would then use more memory, or you would write to a read buffer, something like this, then this would crash. So
okay, so but maybe let me put it this way: can I allocate the memory from inside this code block in C? I mean, like calling the C standard library functions like malloc.
Okay, frankly, I don't know. I read something about memory management with WebCL, and it is still something buggy on this part.
Okay.
So sorry, I can't answer this.
Okay,
exactly.
Thank you very much.
Do we have any more questions?
I want to ask about why browser vendors doesn't want OpenCL. Is it like security or something like that?
Yeah, so WebCL isn't 100% secure right now. That's why it's not introduced by any vendor. You can, if you would want to, you can very easily crash a machine. So in WebGL, they already got around this, right? You can use shaders. They are a bit sandboxed, so there's no worry that something would crash the machine. In WebCL right now, since it's not done by the browsers, it's done by outside vendors. It's still not, it's just that the browser companies didn't really verify this. Probably they are okay. So the Nokia implementation, at least I talked with a guy at Nokia. How did they do the implementation? He said that it is secure. There aren't any issues with this. It's just that Mozilla didn't yet review this code and check this out and allow it to their thing. And Firefox OS also, I doubt it would come really soon, but hopefully it would come in some time, and then we could also use it on devices.
Okay, thanks.
I've got a question about that bit of C code in the example. Is it interpreted or compiled?
It's compiled, so at the very beginning. So it's compiled by the browser extension right now. At least in a Mozilla's implementation, it's compiled. In Samsung's implementation for WebKit, I think they got a different approach, but I don't remember right now.
Okay, thank
I
you.
think it was interpreted, which also is even less secure. Okay.
I think we are done.
Thank you very much.